Hello, this is the solution to the practice problem where you'll be making a velocity time graph out of a PT graph. So first things first, get the lay of the land, get familiar with what's on the PT graph. First thing, make sure that you assign some letters to each segment so that you can keep your information straight. In this case, we have A through E. And we'll start out with A. So we see that A is moving up, and that means that it's moving rightward or upward, and it's a straight line, so it's constant. We can also see that it has a slope or speed at A. We're going to do that final minus initial. Its final position is 30 meters minus its initial, which is 0 meters, all divided by the time, which is 3 seconds where it finishes minus 0 seconds where it starts. And that's going to get us 30 divided by 3, which is going to get us 10 meters per second. B, we look at segment B. We already know from the get-go, since this is flat, that the slope is 0, and the velocity then, or the speed, is also 0. We don't even need to bother with the calculations there. We go on to step C. We now notice that as we move left to right, it is pointing downward, so it must be moving leftward in reality, or downward as it's pointing down, and it's constant, it's not a curve. And to find the speed or the velocity of C, final minus initial, the final is going to be the 15 meters minus the initial, which is 30 meters, divided by 8 seconds where it finishes that interval, to 6 seconds where it started the interval, and that gets you 15 divided by 2, which comes out to 7.5 meters per second. Notice how this is negative, and that makes this negative. So make sure you edit that. So that's a negative 7.5 meters per second. Going on to D, the same exact scenario as B, flat, therefore slope, speed at D equals 0. There's no motion. When we go on to E, we look at E, it's also pointing downward, and that means that it is moving leftward or downward in reality, and it's a straight line, so it's constant. And we can figure out the slope. So the slope of E, or the speed or velocity, is going to be the final position, which is negative 15. Make sure we get those signs correctly. Minus the initial position, which was actually 15. All divided by the time, which was 17 seconds, minus 11 seconds. And that gets us negative 30 meters divided by 6 seconds, which is going to get you negative 5 meters per second. All right, so we've done our analysis, we've done the calculations, and now all we have to do is use those numbers to set up our VT graph. So the scale for time is given to you. So then you just look at your numbers, look at the highest, which is 10. So we're going to get this to go up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try that again. Sometimes you have to erase. We'll do it at intervals of 2. So 2, 4, 6, 8, 10. And negative 2, 4, 6, 8, 10. Make sure you mark those as 2, 4, 6, 8, and 10. This is also -2, -4, -6, -8, and -10. All right, so for the first 3 seconds, it was going at A's velocity, which was 10 meters per second. So you go up 10 meters per second for 3 seconds. Right about there. And then it's going to drop down for B to 0. And it's going to hold there for till 6 seconds. And then it's going to have a leftward velocity of -7.5, so that's somewhere here. It's going to hold that for 2 seconds. And finally, it's going to bump back up at D at 8 seconds. It's going to do that until the 11-second mark. Finally, at E, it's going to head back leftward again, this time only to 5. So we go down to 5, and that's going to carry us all the way to 17, where the line ends. So just a quick recap. This was the 10 meters per second. This is 0 meters per second. This is the -7.5 meters per second. Then this is 0, and then this is -5 meters per second. All right, this concludes the solution to the graphing problem. Hopefully this was clear enough. If you have any questions, please let me know. Thank you.